So today we begin with the second lecture of the dimensionality reduction. Let's have a little recap. In last lecture, what we did was we started off with understanding why we need dimensionality reduction. There are three important aspects to it. The first one is that we need a simpler solution. We need a less complex one, so we reduce the dimensions. Then in order for us to make better visualizations, we need dimensionality reduction. And third was the requirement of data compression. There are two methods by which we can do dimensionality reduction. The first one is the feature selection, and the second one is feature extraction. In feature selection, we've got two kinds of methods, filter methods or wrapper methods. Filter methods rely on statistical measures and they do not involve the use of learning algorithm while selecting those features. However, wrapper methods make use of the learning algorithm while they're choosing or selecting which features to keep and which to let go. In this regard, we did genetic algorithm. Genetic algorithm has four primary or important phases. First one is the coding or representation of the problem at hand. Second is the fitness function. The third was the population generation, and fourth is convergence. In coding or representation, we see how we can convert our real world problem into an appropriate representation that can be worked upon through your computer. While in fitness function, we decide that which parameter will we use in order to see if our function is effective or not. The third step is the population generation. In population generation, we choose some parent individuals of the previous generation based on their fitness values or fitness score, and then we use crossover and mutation in order to generate a new population. And the final is convergence, deciding when to stop your genetic algorithm. Today we'll be covering feature extraction, which is the second method by which we do dimensionality reduction. Feature extraction can be done in a supervised manner, or it can also be done in an unsupervised manner. In unsupervised manner, we've got a technique, principal component analysis, and that's the one that we'll be covering in today's lecture. The other techniques are independent component analysis or ICA, and in the domain of supervised, we've got linear discriminant analysis or LDN. Principal component analysis is one of the most common feature extraction technique. It reduces the dimensionality of dataset by finding a new set of variables smaller than the original set of variables. So what we do is we take the original set and we perform some action on it, generate a new feature set, and this new feature set is smaller than the original one. The one that we use from the new feature set is smaller than the original one. So it allows us to combine a lot of information contained in the original features M into new features N, where M is much smaller than N.